This video is about compound interest and how to calculate it. Now this is in the context of our exponential functions and definitions and understandings, and it's relevant because compound interest is done exponentially. We're going to compute compound interest with the following formula. We're going to say a of t equals capital P times, now in parentheses, 1 plus r over n. Now that would be like the base of the exponential structure we have going here, all to the power of nt. And so given the way we've defined this as a of t, t is our main variable. Notice when you have your main variable in the exponent, you can utilize an exponential definition for this function. Now, specifically for compound interest as it relates to this formula, the pieces mean as follows. A of t is the amount after t years, P is the principal, R is the interest rate per year. Now, that's usually given as a percent. We're going to write that as a decimal, however. So even if they give you, 6%, we're going to write 0.06 instead so that we can use it numerically as a decimal. N is the number of times compounded per year, and then t is the number of years. Let's consider some commonly used compounding frequencies. So compounding occurs when the interest is applied to an account. If you've ever experienced some kind of savings account at a bank where they do provide some kind of interest, usually it's not much, but on a statement, if you look back, usually it's done maybe quarterly, or banks may do it in different frequencies, but when it's compounded, they actually compute the interest and then add it to the account. So compounding frequencies can vary, and for our purpose, we're going to understand some of the basics. Annually means once a year, semi-annually means, or biannually, same thing. Semi-annually and biannually mean twice a year. Quarterly means 4 times a year, monthly 12, and daily 365. And so basically these are the n values that might be showing up in our formula. Let's try an example such as if $6,000 is borrowed at a rate of 5.25% interest per year, compounded quarterly, there's our key compounding frequency word, find the amount due after 4 years. So we want to first of all understand that this is compound interest. Not only is the word compound in the problem, but when you utilize some kind of percentage rate like this, and it's happening over and over again, that's often how the behavior of a compound interest function works. So we're going to copy down our formula and then see if we can identify the key pieces. The formula was A equals P times 1 plus R over N to the NT power. And then of course we'll refer as needed to the definition of what each of these letters means. Now the question was to find the amount. Well, that's A. But we want the amount due after 4 years. So let's go ahead and plug in the numbers we have from this problem. First of all, principal, that's your initial or starting amount. And they say if $6,000 is borrowed, so we're going to put 6,000 as our principal. And then inside the parentheses, we'll say 1 plus, and then we have R over N, but remember, we write the rate R as a decimal. So 5.25%, we can turn to a decimal if we move that decimal point in the percentage number 2 values to the left. So we'll say 0.0525, that's really 5.25%. And then we want over N the number of times compounding, but notice if it said quarterly as it did, that means N would be 4. That's 4 times a year. So we'll put a 4 in for N. And then our exponent outside our parentheses is N times T. Well, we know those values because N is 4. And T is the number of years, the duration. And they gave that to us as 4 years, so that's a 4 as well. So really it's a 4 times 4 out there as the power. Let's take out our graphing calculator and see if we can compute this result from the compound interest formula. We're going to type it in pretty much as we see it. So we'll type in 6,000, which was the principal value way out in front, and then parenthesis opening, and then inside the parentheses we have 1 plus, and then the fraction, which was 0.0525. So we'll type it in just as we see it, and then we'll do divided by 4. That was the N value. Now we're going to close up parentheses, and thanks to the fact that our calculator understands order of operations, the way we have it typed in is fine. You don't need extra parentheses surrounding the 0.0525 over 4 as a fraction. It'll understand and do that correctly before the addition for us. But then outside we have this exponent, so we'll hit to the power of, and then 4 times 4, we'll just turn that into 16, or you could just type in, if you'd like, 4 times 4. Now we'll just hit enter and see a value it computes for us. Okay, now this is money if you read the context of the problem, which means we're naturally going to round to the nearest hundredth, since that's the smallest unit of money we have. So we'll say this is $7,391.96. So there's our formula in action working for us. Now, of course, things can vary so that, if the compounding frequency is different, you're going to be plugging a different value in for n, but it's the same formula. And as we saw earlier, there are different values for n shown in this table in our notes that might help out.